Okay, find the Taylor polynomial degree n at x equals c. So here the Taylor polynomial is just slightly different on the formula. You do the nth derivative still, but you evaluate it at c over n factorial, and then you center it, you do x minus c to the n. So we still kind of have the same process. It's just we're going to evaluate the derivative at a different point. So I'm going to make my table of nth derivatives, right? When n is 0, it's x to the 1/2. Then the first derivative is going to be 1/2 x to the negative 1/2. The second derivative is going to be negative 1/4 x to the negative 3/2. Then it's going to be positive 3/8 x to the negative 5/2. And for the fourth derivative, it's going to be multiplying this minus 15 over 16 x to the negative 7/2. And then we're going to evaluate this at c equals 1. So instead of 0, we're doing 1. So square root of 1 is just 1. 1 to the any power is just 1. So this would be 1, 1/2, negative 1/4, 3/8, and negative 15 over 16. And so our series is going to be 1 over 0 factorial, x minus 1 to the 0, plus 1/2 over 1 factorial, x minus 1 to the first power, then minus this 1/4 over 2 factorial, x minus 1 squared, then plus 3/8 over 3 factorial, x minus 1 cubed, then minus 15 over 16 over 4 factorial, x minus 1 to the 4th. So this is all just 1. This is going to be 1/2 x minus 1. 1/4 over 4 is minus 1 over 16th, x minus 1 squared. This is 3/8 divided by 6. That's 1/16th. Wait, 3/8 over 6 is, that's going to be a 2. Yeah, 1 over 16, x minus 1 cubed. Then 4 factorial is 24, so 15 over 16 times 1 over 24. That becomes 3. That becomes 8. Sorry, 5. Dividing both by 3, and then I can't do it, so it's 5 over 128. This is going to be minus 5 over 128. X minus 1 to the 4th. Okay, so exact same process, just that you have you're centered a little differently, and then you're plugging in c into the different nth derivatives. So n equals, so if we do our table for n and f to the n of x, when n is 0, that means no derivatives, cosine x. 1 is negative sine x. 2 is negative cosine x. Next derivative is positive sine x, then cosine x, then negative sine x, then negative cosine x. That. 4, 5, 6. So the nth derivative at pi over 4, well, cosine of pi over 4 is root 2 over 2. So is sine pi over 4. So negative root 2 over 2, negative root 2 over 2, positive root 2 over 2, positive root 2 over 2, negative root 2 over 2, and negative root 2 over 2. So then this series is going to be root 2 over 2, 1 over 0 factorial, x minus pi over 4 to the 0, minus root 2 over 2, 1 over 1 factorial, x minus pi over 4 to the first power, then minus root 2 over 2, 1 over 2 factorial, x minus pi over 4 squared, then plus root 2 over 2, 1 over 3 factorial, x minus pi over 4 cubed. Then we're at 3, so at 4 it's plus root 2 over 2, 1 over 4 factorial, x minus pi over 4 to the 4th, and then minus root 2 over 2, 1 over 5 factorial, x minus pi over 4 to the 5th, and finally minus root 2 over 2, 1 over 6 factorial x minus pi over 4 to the 6th. And the only thing I would simplify were to do this is just to make this like 1 right here. But that would be my answer. I'm not going to... like, that would be sufficient. You could evaluate the factorials if you really wanted to, but they're going to be like really big numbers. So, Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.